In this video, I want to show you how to use this Android pointer program to troubleshoot your indirect addressing programs that are developed in STL. The software platform could be Step 7 and the newer platform that is TI Portal. I'm testing with TI Portal version 16, and it's possible to test with previous TI platforms and Step 7 platforms. In this example, it's a very simple pointer application. I initialize the address register number 1 and address register number 2 with byte number 0 and bit number 0 in a arbitrary data block and data instance block. This section is a loop, and the loop counter is around 992. I made a copy of address registers in this point because a loop in Step 7 is executed in one cycle. So I need to make a copy of the pointer in each cycle because it's very helpful. If I made something wrong, it will reveal the point of error for me. In the next part, I open the source DB. I point to a cell in this DB, open the next DB, and in the content of this cell in the first DB is copied to the content of the cell in the second DB. Iteration. Address registers are iterated, and loop is started the next iteration. And the DB source and target. It's an array of Boolean variables, and if I go online, you should see all elements are true. It's the source data. I initialize the source data in the startup part of the program, and the target should be true because I copied the exact cells from the source to the target area. And there is an programming error section. I capture the first and the last address register, the first and the last point of error here by this code section. And as you can see, nothing is wrong in this program. Everything is calculated fine, and the program is working perfectly. And it's possible to have a look here. Yeah, the last pointer address is this value, and it's possible to reverse engineer this value by using this program. Because it's a crossing area, you should select the cross area, area pointer, area crossing, and reverse calculation. Here we enter this value in the hex format 8400003DF. We enter the same pointer value here, and we want to see what's the exact point of memory in the S7 PLC that we are leaving in this point. The first variable is pointing to global DB, DBX, and the last address is byte number 123, and the last bit address is 7. And let's have a look here. Let's have a look here. And it's perfectly calculated. The last pointer is pointing to byte number 123 and bit number 7. And if we check the next pointer, it's pointing to another value. We enter the same value here, 850003DF and hex, and it's pointing to an instance DB. It's perfectly normal because we use the source as global data block, and the instance the next the target as instance DB to transfer, to open the DBs and transfer. Everything is working perfectly here, and the next step is to change the user program to generate some input, read and write access errors. We increase the loop counter in a manner that CPU search for non-existing memory areas, and we need to find out what's the trouble, what's the reason of system function in the CPU, internal or programming error in the CPU. For that, it's possible to check the diagnostic buffer. In the diagnostic buffer, we have a huge amount of area length error while reading and writing. We want to find what's wrong here, and you can see that we have we captured the first point of error for DB1 and the first point of error for DB2. This pointer is a non-existing cell in the data block. Let's see, and let's ask the application for help, and let's find what's this point represent in a S7 data block. It's 3E0. This code it's in instant DB, and I want to calculate that for global DB. This pointer points to byte number 124 and bit number 0, and it's in source data block, and we don't have this byte number in the data block. We have only the byte number 123 till bit number 7. We don't have one cell. We don't have this cell 124.0. We don't have this, and the last point. So the pointer error is this, and simply it's possible simply it's possible to use a calculator. Use a calculator to calculate 124 multiplied by 8 is 992. This is the legal value of the loop counter, and the first illegal address or non-existing address is byte number 124, and the last one is 07C7. Let me try again. 84. You should follow the syntax. 840007C7, and it's pointing to byte number 248 and bit number 7, and it's obvious that it's a non-existing memory area in that DB, and same is to the target DB, because they are exact DBs. And the solution is to change the loop counter to 992. Download the program, and everything is fine here, and you find out how this application will help you to troubleshoot your pointer program in S7 technology. In TI Portal and Step 7, it has, this application has and now it has 4 modules. It covers area pointer, DB pointer, A and Y pointer. It has a forward calculation and reverse calculation, plus and help for providing you the basic guide for each term used here, and you can use calculation, pointer addition, subtraction. Possibly in future I will add some special button here for user of this application to gain or to have access to some videos and to help them more about these topics. I hope you find something helpful here, and don't forget to join and subscribe to our channel.